Hello, my name is Marianne Neihart, and I'm the host for this episode of The Footprints of Pacifica, brought to you by the Pacifica Historical Society. This is the show where we discover and explore the lure as well as the lore of Pacifica and its character as well as its characters. Today we're going to start with the first of two episodes concerning how we manage wastewater treatment or sewer here in Pacifica. It's got an interesting history, and I'm very fortunate to have both a friend and a former city employee who is probably the best expert we can have on this subject, Scott Holmes.
Well, I'm glad to be here.
Well, welcome, Scott. And I just want to elaborate a little bit. You have had 25 years working in the city, and 10 of those years, I believe, were as a wastewater manager, and 15 were actually as the director of public works. Am I right?
That's correct.
Okay. Well, you have a professional engineering degree. I just want to make sure people know that, in civil engineering, as well as a master's in environmental engineering and hydrology from UC Berkeley. I believe you worked designing plants before you even came here?
You know, I did for about 4 years, 5 years.
But it's interesting, when you and I were preparing for this show, you actually had some funny little contact with Pacifica before you even got here. Is that right?
Yeah, I had a couple of different classes that they tour Pacifica for great examples on either how to do things or how not to do things in some cases. So.
And that was related to clean water grants?
Yes, I had some environmental engineering classes that came and visited the wastewater plant that wasn't working at the time as an example of how not to put together a secondary plant. So we all kind of chuckled at it, and I never really envisioned I'd ever actually work here.
And then here you are.
Yeah.
Well, we're going to back up and kind of do a little exploration of how we got there. And I'd like to sort of start with what we're working with. I think we've put together some pictures that might help the public understand how we developed or didn't develop a sewer system here in town, because you pointed out it wasn't a planned city.
No, it evolved, and that's probably been covered. But
well, let's look at a couple of pictures here, just so people have some perspective.
Yeah, this is it's the first survey that was done in Lindemar Valley in 1853, and it shows a large lake at the bottom, which was called Lake Matilda by the farmers, and then a large riparian zone all the way up to the adobe, which is located up here. And this is the large floodplain associated with a creek. It's pretty flashy. It flows up to levels of the American River when there's a stalled storm on it. And at this picture, the stream was actually on the north side over by Crespi and still discharging about the same location out of Lake Matilda.
Well, when you think about it, all of Lindemar on the front end of the valley was basically below the water table or below sea level.
Yeah,
right?
Sea level was the lake, and it would fill up. The dunes would break through, and the ocean would fill up the lake, or the creek would back up and fill the lake up. So it was very...
yeah.
Yeah.
And then when we think about where the Sharp Park plant is, we can look at this picture.
Yeah, and this is Lake Matilda down at the bottom, and all these valleys are isolated little valleys that are separated by fairly steep hills, and this is Rockaway and Valimar, and then Sharp Park. And actually, even the Indian villages were somewhat separated that were in these different valleys. So the sewer systems just evolved in the different valleys, from septic tanks to collected sewers to larger community tanks.
Well, let's take a minute here and kind of think about this, because those are the coastal maps, and that's the terrain of town. You were trying to explain, based on that terrain, a little bit about how the farming community managed wastewater early on. So why don't you start with that and then catch us up kind of through the 30s?
Well, when separate farms, they had primarily septic tanks or leach pits or something, but and same with the smaller fishing shacks that came up, and the subdivisions really didn't show up until the railroad times. Between the late 1880s and 1920, each valley was a kind of a real estate venture that had a station and lots. And the older houses in Sharp Park, well, this is North Pacifica. North Pacifica developed a little bit later. It was a pig farm initially. And then in the 40s and 50s, all the houses showed up. But and in that, it
So
gradually...
basically, we were dealing with a series of septic tanks.
Yeah.
Okay.
And they connected to Sharp Park, which was an older community than North Pacifica. There's some pictures of Sharp Park in there, but the railroad developed Sharp Park and put in sewers that initially just discharged into the ocean. And by the 20s, that was getting unacceptable, so they collected it into a large, what they called an Imhoff tank, which is a giant septic tank. And that would fill up during the day, and then at night it would be drained out when assume nobody was out there. And that was the same in, they had one in Rockaway that served Rena Del Mar and Rockaway. And Lindemar was septic tanks in Pedro Point and farms in Lindemar Valley.
So we had a large septic system in Sharp Park, another one in Valimar and Rockaway that were kind of the Imhoff tanks that you were,
yeah.
And then just still septic systems on both Pedro Point and in Lindemar up to when?
Up till 1965 for Pedro Point, but in right after the war, the Lindemar subdivision started going in the early 50s, and they stacked up one after the next. There were 5 subdivisions up till all the way up to the Adobe, and each subdivision was designed separately with small sewers, 6 and 8 inch sewers. And then the next one behind it would just connect to it. And pretty soon the sewer lines were overloaded. And they went to, by the 50s, they built a primary plant at the bottom of Lindemar to handle these new subdivisions. But most of the lines by the mid-50s were full and overflowing into the creek. And the collection system operators, rather than flood houses, would just make a bypass into the creek or into the storm drains. So that's how Lindemar evolved all the way up to the 60s.
So let's so they started with 300 or so houses in the front end.
Yeah.
All of those being kind of on Lake Matilda.
Yes, they put in a thin layer of dirt on top of Lake Matilda. The farmers would sort of fill it in so they could grow artichokes. And there was a little bit more dirt added. But Lake Matilda still wanted to reform every 10 years when Lindemar would flood. The creek actually was channelized in a very small channel, and that would flash out and flood lower.
So if they have these pipes and things that are all kind of leaking in different places, and then you have a flood, what happens?
Well, again, Lindemar would fill up, and the Highway 56 and 1 was kind of a dam, and until it spilled over the top, everything would flood to 6-8 feet of water.
Okay.
And all the sewers are below water table at that location. Some of them actually have to flow uphill to get to the pump station.
So as they built each of these subdivisions, you started out with a certain size of pipe, right?
Yeah, the bigger pipes were 10-inch pipes, about that large.
But then they add subdivisions?
Yes.
They kept increasing?
And also in the conditions with the flow that was coming from the creeks and the valleys, these pipes would just be full and pressurized. And it would come to a house, and if the house was lower than the pressure level, the house would fill up with sewage. So the collection system guys literally would tap off that line from a manhole and dump it into the creek to keep the houses from flooding. And then when the creek got high, it would come back up the sewer lines and flood the houses with creek water. So it was kind of a hard struggle to get things from one end of town to the next.
When you're talking about the subdivision at the front of Lindemar, that was really sort of self-contained and had a pipe that went to the ocean. And that pipe was 6 to 8 inches, somewhere in 8 inches, 10 inches.
To maybe 10.
How big is the pipe? How big are the pipes now?
Well, we had to, by the time, in the early 80s, we had to build a trunk line system that went all the way up Lindemar Boulevard and up into Park Pacifica. And at the bottom, they're 24-inch, 30-inch pipes.
So
And there's some pictures of those. Would be one. That happens to be Sharp Park, but that would be typical of the type of pipes that we put in. And that was because even though there was a plant in Lindemar at the time, it was only getting maybe 25% of the flow that was being generated from the early subdivisions.
I just want to make sure that the audience understands what it is that we're talking about. So if you only have 300 to 400 homes going into a smaller pipe, but then you add more homes and more homes and more homes as you go up in the subdivisions, that pressure increases in those pipes, yes?
Mm-hmm. And the pressure level will exceed the street level or exceed the house level, and then it overflows.
So looking at this picture again, if you look at how big these pipes are that we needed finally, the size was quite disproportionate to what we were actually needed. That's why things began to back up in some of the floods.
Yeah, and it was just an issue of trying to get all of the sewage to the pump stations or plants. Just wasn't happening.
Okay. Well, let's back up then how we begin to bring this together. So the Manor and the Fairway Park neighborhoods were brought into Sharp Park first, right?
Yes.
Do you want to elaborate a little bit on how those came together?
Yeah, and then in 1950, that flow resulted in the first upgrade of the Sharp Park primary plant. They went from an Imhoff tank, which was just a tank that you don't remove the sludge out of, you just let it collect. And in this case, they just discharged it. But to a primary tank where they separate some of the solids, the larger chunks from the wastewater before they discharge. And they put the first Sharp Park outfall in 1950. And at the same time, they were building a new primary plant in Lindemar, and they put the first outfall in 1950 there also.
So we ended up with two primary plants at that point.
And
okay.
two separate sanitary districts at that point also.
Okay. And then in the 60s, that first force main went in?
Well, in the 60s, they still, the city in 1957 consolidated the sanitary districts. So we ran two separate plants up until, up until 72, but both their outfalls failed by the mid-60s, and they put new outfalls in both Lindemar and Sharp Park, so that's 4 outfalls that they've constructed. And then in 1972, they decided to consolidate all the plants at Sharp Park, and they replaced the plant in Lindemar with a large pump station, but not large enough, because again, they didn't recognize how much flow would have been showing up.
Let's stop for a second and take this kind of one piece at a time so people understand. What happened in 1972?
Well, the Clean Water Grant Program started, there was a concern throughout the country that sewage was treated fairly casually. It would either make it to a plant or it would overflow or in a creek. But the pollution problems in the Bay Area and urban areas were very high. The bay was very polluted. The beaches along the coast were very polluted. So they started funding new regional plants, and Sharp Park was selected for that. And they estimated the flow would be about 8 million gallons, 4 to 8 million gallons. So that's how big they built that plant. But the actual flow was closer to 25 million gallons. So the plant was immediately overloaded, the primary plant. It would work.
Wait, let's back up.
Back up. Good.
So
charging ahead.
You really are good at this. But so you have all this in 1972. The city decided to bring everything together. They put it all in Sharp Park, and they built a plant.
Yes, and this is kind of a picture of that plant, which is...
That's kind of where I wanted to go, is to make sure that you got a sense of this. This was, what aspect of the plant's being built here?
Those are the primary tanks for Sharp Park, built in 1972.
Okay.
And
if we look at this picture, I'm going to switch that out.
We're still primary tanks, but that's the 2
There we go.
digesters. And they... that was the difference between primary, is they pulled the solids out and digested it and handled that separately.
So you can see back here is the plant
City
building.
Hall, yes.
The city council chambers as it stands
City
now.
Council chambers.
But it was the main offices for the plant, right?
Yeah, it had the lab in it. It was always the council chambers, actually, upstairs.
The upstairs from the
Yeah.
time it was built? And it
Yes.
was built when?
In 72 and
Okay.
finished in 75. And the Clean Water Grant Program switched from, in 74, to a requirement mandatory secondary treatment, which was a biological removal of dissolved organics. So they just continued on from the primary plant and built a secondary plant.
So let's go back to this picture. So all we have here on this site is really primary treatment at this point.
At that point.
So we have these things here on this side are,
The settling tanks. Where
The
the
settling
chunks,
tanks,
Chunks
okay.
settle out, basically.
and then the digesters are over here.
Is where you take those chunks and break them down.
Okay,
And then on
it's
the other
past
side
that.
would be the secondary plant, yeah.
So at the beginning, they said only primary treatment had to be kept out of the
Yeah.
ocean. And by 74 or so, we had to keep secondary.
Yeah, and that was all over the country. It had to be at least secondary treatment
Okay.
level. And they built the pier at the beginning also. That was part of the primary plant, was the third outfall at that time for Sharp Park.
So we had an outfall in Lindemar, and a
Two
third
different outfalls at Lindemar and
outfall.
3 outfalls at Sharp Park.
Okay, got it.
And the reason for that, the ocean is just rugged on outfalls. The bottom conditions change up to 10 feet in a storm. It's either exposed or it's buried. The diffusers get buried. It was a very difficult process to operate, actually.
You now were starting to explain to me what was it about the primary treatment and the plant and the digesters that never worked from the beginning in Sharp Park.
Yeah, the primary plant worked okay. It was a bit overloaded, but the reason it worked well was it was only seeing about 7 to 8 million gallons a day. And there was a bypass at Paloma that was about 3 or 4 million gallons a day at peak weather conditions. And then Lindemar Pump Station would overflow.
And when you say bypass, what do you mean?
It just meant it came to the manhole, couldn't make it to the plant, and flopped out onto the beach at that location.
He dresses it up. I wanted
Yeah.
the public to be aware.
And the Lindemar
Yeah.
Pump Station could pump about 3 million gallons, but it really saw 10 million gallons. So about 7 overflowed into a ditch right in front of it and was pumped into the bay.
Okay.
The
And then in the plant, when you got into secondary treatment, you also were telling me about some organisms or something that weren't actually working, and a funny dog story.
They had, it was one of the first secondary plants that came along using a traveling bridge, one of the very few of them, and they couldn't control the wasting, so the solids would just build up in the plant, and it went for 5 years of operation and never met its secondary requirements for a single day. And it would build up solids to the point that it would get a, what they call a smooch sticker, but a large hard layer on top of the clarifiers that would actually have plants growing in it. And there was one episode where a dog ran into the plant. It ran around for a while and then finally broke through. And the superintendent at the time reached through the sludge and groped around, and actually the dog found him and pulled him up, chomped on his hand. But it was, they just had a lot of difficulty. The plant, we finally got it working in 1983 during the summer. It would actually work under dry weather conditions, but we had to put in a wasting trough that allowed us to regulate the wasting in it. And maintain
Well, you were explaining to me about these organisms, just to give people a sense of the magnitude. It was something like you would get 250 and it was supposed to be at 30. Okay. What do you
Yeah,
could you explain that just a little bit?
There was a discharge requirement at secondary, which was 30 milligrams per liter of organic material, and solids was the same.
Yeah.
And coming into the plant was about 250, and by the time it was finished growing organisms in the secondary plant, the typical effluent was around 150 to 300. So a lot of times it was higher coming out than coming in.
So we were making
sewage.
Okay.
So
that's how that crust forms, and I wanted people to kind of understand that that's why the system kept backing up. So with this peak problem and the organic problem, your first day on the job must have been pretty tough.
Well, it was kind of interesting. The regional board was suing the city because there was 5 years of no operation discharge being met.
And the city was suing?
Was suing the engineers, and the engineers were suing the operators. And the regional board just said this had to be resolved in the plant. They gave a deadline for the plant to be operating. And we put in, again, wasting troughs and then changed things and got it to work in about 8 months, or 8 or 9 months by 1983. And it actually worked all summer of 82 and 83. And it wouldn't work in the winter, but it would work fine in the summer. The way it worked in the winter is we just bypassed the majority of the sewage that came down the
You
the
gave
pipe.
me a percentage.
Well, until we fixed the collection system, we bypassed about 60% of it. But once we focused on fixing the collection system, the bypassing was closer to 80%.
Now,
90%.
given the floods in Lindemar, and people remember the stories of the tops popping off of the manholes and some of those kinds of things, you brought some pictures also of fixing the collection system, bringing it all into Sharp Park. You want to share those?
Yeah, and the biggest problem we were facing, we had a secondary plant that worked to about 6 MGD, mostly an average of about 3, but we still had...
So here's an example of some...
Yeah, that's... There are a couple of... Peter Loeb is in the picture, one of the previous mayors, and here he is again talking to the...
and I think here's a different
Tribune person, Bob Verdickberg. And basically we put a big force main, or not, trunk sewer up Palmetto that collected everything on that end of town and got it to the plant and eliminated the Paloma overflow.
I think this is a good example of how big those pipes are.
We went from a 10-inch, I think, and to that's about a 22-inch, I think, clay or 20. And the same thing at Lindemar, we had to run a big trunk sewer all the way up to Odsted to pick up.
And here's an example of what you were doing in Reina Del Mar.
Reina Del Mar, same thing. We had to get that sewage out of the creek and to the plant. And the inflow was really high, but we did a lot of smoke testing and determined most of it was still laterals at that point. And we were under the gun for a cease and desist order, so we managed to get all the sewer trunk lines grant funded and got it all to the pump stations and to the plant.
You had a great story about that at the Masonic Lodge, didn't you?
Yeah, there are actually some pictures of it. Some of the force mains that we put in, those are 2 pictures there.
Here it is.
And there was an older line that collapsed and sucked in the vegetation that they just put in on Easter during an Easter egg hunt. And there are a lot of little
So this is the
situations like
Masonic
that.
Lodge right here.
Yeah.
And so it kind of backed up or it broke
Well,
loose?
it rotted out. They put in a water pipe instead of a sewer pipe. It only lasted about 8 years, 6 years.
So here's this pipe coming in that didn't work, and there was a swirling mass of sewer that literally sucked the trees down.
Yeah, small trees into it.
That they had just planted.
Yeah.
So
So it kind of freaked people out. But one of the problems, when they consolidated the plant, they pumped everything from Lindemar, but they used a concrete steel cylinder pipe that collapsed in about 8 years. So we replaced that mostly with polyethylene. So the effort was not only to just get it to the pump stations, but get it from the pump stations to the plant. And ultimately, we ended up with 20 to 25 MGD at the plant with a capacity of 3 MGD. So that got us through the 80s.
So
but
you had how many million gallons a day
Well,
getting to Sharp Park?
peak flow, by the time we got it off the streets and to the plant, was between 20 to 25 MGD. And the plant at Sharp Park had
That's
a 3
million gallons a day.
million gallons per day.
Yes.
Yes. Had a capacity of 3 million gallons a day. And since it worked well in the summer, the regional board was okay with that, but they weren't okay with it in the winter. And by 1993, they calculated a new fine for the city. We actually were fined $12 million in 1982 for the old plant, but the new fine in 1993 was $1.8 billion. So that
We didn't pay
we didn't pay
these.
it. We worked it out, but it was still kind of interesting because they started charging us for all the untreated secondary sewage.
So the bottom line, and didn't you upgrade the Lindemar plant at the pump
Yes,
station during that time also?
We had a big goal was to get it off the beach in Lindemar because
Okay.
the flows were in the winter were almost complete bypass at Lindemar and
Okay.
complete bypass at Rockaway, and also at Fairway Park. They just turned the pump stations off. There was not enough capacity to move it, and so now it's all. It all ended up at Sharp Park at that point.
So Scott, you inherited a plant that wasn't actually working. You got it up and running and working. You built collection systems that brought from all the areas of town everything to Sharp Park. Now you're at 1994 and you're facing how much?
Well, they wanted full treatment of all the wastewater, and they sent a fine out letter to us. They calculated all the wastewater we had bypassed for the last 5 years, and the fine was 1.8 billion by the time they multiplied all the dollar figures and that. So the new, like the big issue in the 80s was to get it to the plant and to get some function during the summer. The big issue in the 90s was to treat it all, and the big issue in the 2010s will be to reduce it, to treat it more safely.
Well, it's interesting. That's exactly what we're going to get to in the next episode, because basically what we've gotten to is 1994 and a major crisis in town, because we have this huge fine, which we didn't have to pay thanks to you and the efforts of the city. But I have to say, we had a lot to do to make that not happen. So in the next episode, we're going to talk more about how the city dealt with the 80% bypass that was happening sometimes in the winter. I do recall a period of time we were out of compliance 30 of 31 days. So we're going to look at some of the citizens that helped with that. We're going to talk about the new Calera Creek plant, and we're going to take a little tour of that with our current operator, our current director, who's Dave Grom. So it seems like we're out of time for this episode. Scott, thank you so much for joining us and for bringing the pictures. I definitely want to thank the Pacifica Historical Society, and if you would like to get these episodes or review them, to contact Kathleen Manning at 359-5462 or visit the website pacificahistory.org. Thank you so much, and thank the audience for watching. It's kind of fun.
Yeah, it is, and
It
believe
goes
it or not,
quick, doesn't it?